Hello, this is Ms. Prather, and today we are going to be working on factor by grouping. As you see here, I have two examples, and I will go over how to do each example. So we're going to start with the first one, 8r cubed minus 64r squared plus r minus 8. The reason that this has to be factored by grouping is because if you remember the definition of factor by grouping, it is when you have four or more terms. And when we group, what we want to do is we want to put two of the terms together. So typically, the first two terms will match up. 8r cubed minus 64r squared. And I'm going to group that together because I know that I have a GCF between the first two terms. And then you have the last two terms, positive r or plus r minus 8. And so I'm going to group those together, and I'm going to take the sign of the r as well, so I'm going to include that plus with the r. Okay, and again, remember we have to be factored by grouping because not necessarily, if you look at the 8, 64, 1, and 8 again, may not have the same GCF, as you'll see in example number 2 as well. So with the first group, 8r cubed minus 64r squared. What I'm going to do, my goal is to factor out the first two. So what I will have is the 8 and the 64. I want to find the GCF between of 8 and 64. So I know the factors of 8 are 1, 2, 4, and 8. And then the factors of 64. Now rather than completely factor out all of 64, I know the highest possible GCF that I can have is 8 because the largest factor of 8 is 8 itself. So I'm going to start with 8. And I know 8 can go into 64. So therefore, without even having to check 4, I know that the highest possible GCF between the two numbers is 8 itself. So I'm going to write this over here, GCF 8. Okay, then I also have this r cubed and r squared. I'm going to expand that r cubed, and then I have r squared. Now I'm going to partner up my r's. As you see here, I have two partners. This r cannot partner with anybody because there is not an r below here. So my GCF for the r's is r squared. I'm going to put that together, and I have 8r squared as my first group with my GCF. So I'm going to rewrite that. Now I'm going to have my parentheses. Now I have to figure out what is left behind. 8 divided by 8 is 1, so I put the 1 here. I had initially 3 r's, and I took out 2, so I'm left with 1 r. Minus, still keep that sign, 64 divided by 8 is 8. I had 2 r's initially. I took out 2 r's, so I'm left with no r's, so I'm going to close it. Now when I look at the plus r, which I know there's a 1 there, minus 8. I'm now into my second group, and I'm going to figure out the GCF of 1 and 8. Or negative 8, as you could say, but we can just say 8. 1 and 8. Well, the only factor of 1 itself is just 1. And since only 1 is the only factor for 1, I know my GCF between 1 and 8 is 1. Okay. Now, the r has the one variable r, but the 8 does not have a variable. So therefore, I cannot make any pairs that do not have a GCF with my variable. So my only GCF that I can pull out for 1r minus 8 is just 1. And on the inside, I have 1 divided by 1 is 1. The r never came out. It's still on the inside, so it has to stay. And then 8 divided by 1 is 8. Okay, so here we go. I have this factored out. What I have in the front that I'm about to circle, 8r squared and 1 those are my two GCFs. I'm going to put both of my GCFs together. So I have 8r squared. This one, you do not see a negative in front of it, therefore it is positive. And I combined my two GCFs. 1r minus 8 and 1r minus 8. Because you can see it 2 times, we don't need to write it 2 times. So all I'm going to do is just rewrite it 1 time here. So for this example, to factor by grouping, the answer is 8r squared plus 1 times 1r minus 8. Now, if you wanted to check yourself, you could do the box method with these two binomials, and you should get back what you started. That is a great way to check yourself on the test. We're going to go ahead and move on to example number 2. And as I said, this is still factor by grouping because you can see you have 4 terms. 1, 2, 3, 4. Okay, and if we were to try to find the GCF of 12, 21, 28, and 49, the greatest number that they would have in common would be 1, because 21 does not necessarily have the same factors as 49. So therefore, that is why we have to factor by grouping, because we know that when we put the first two terms together, we will have a GCF that we can pull out. And when we put the last 2 terms, be careful to take that sign with it, we will then find the GCF. So as I did with the first problem where I pulled it out separately, I'm going to start with the first group. I have the GCF of 12 and 21. I'm going to list all my factors of 12. So that's 1, 2, 3, 4, 6, and 12. Now, there's no need for me to list all the factors of 21 because I know that the greatest number I have, it can be 12. I know 12 cannot go into 21, so that can't be the factor. The GCF, I know 6 cannot go into 21 evenly, meaning that if I divide 21 by 6, I would not get a whole number. I know 4 cannot go into 21, but I do know 3 can go into 21 because 3 times 7 is 21, so 3 must be my GCF for this number. Then I have p cubed, so I'm going to go over here and write my p 3 times. And then I have p squared. I'm going to write my p 2 times. I'm going to use my handy dandy highlighter to partner up my groups. So my GCF that I have here, I have 1, 2 groups, so that is p squared. I'm going to put those together, and I have 3p squared. That's my GCF that I'm going to pull out and leave on this outer part, 3p squared. Now I have to figure out what stayed behind on the inside. 12 divided by 3 is 4. So 4 stayed on the inside. I had 3 p's, but I took out only 2, so therefore 1 stayed on the inside. 21 divided by 3 is 7. I had 2 p's, but I pulled 2 p's out. Therefore, I do not have p's on the inside. Now that I have finished factoring out the first group, I must now come and factor out the second group. So again, find the GCF of 28 and 49. I need to list all my factors of 28. So it'll be 1. And if you don't know all the factors straight across, you can ask yourself, 1 times what number gives me 28? And I know that that is 28, so I'm going to put that out here. Then I know 2 times 14 can give me 28. And then, will 3 go into 28 evenly? No, it won't. Will 4 go into 28 evenly? Let's see. 4 times what number will be 28? And if you're still not sure, this is for you guys that are not sure about your multiplication. You come over here, say 4 times what? I'm going to test 7 because I know 4 times 6 is 24. So 4 times 7, if I added 4, that would be 28. So I know I have 4 and I have 7. And those are all my factors of 28. Okay, so if you're not sure about your factors, do the guess and check over here. So I'm going to start with 28, Can 28 go evenly into 49? No, it cannot. Can 14 go evenly into 49? No, it cannot. Can 7 go evenly into 29? Yes, because I know 7 times 7 is 49. So therefore my GCF between both of these numbers is 7. And then I have one P here. This 49 does not have any P's. So I do not have a GCF with just my variables. Okay, so my GCF, the only thing that I'm going to pull out is the 7 out here. And I have to see what stays behind. 28 divided by 7, we already said was 4. And that P stayed on the inside. Minus 49 divided by 7, that is 7. And this did not have any P's. So therefore, there we have it. Now to check ourselves, if I did this correctly, I would know that I would have the same inside of both of my parentheses. And I do. So therefore, I know I'm on the right path. I'm going to circle my GCFs of both groups, and I'm going to put them together, 3p squared. Now 7, because I do not see a negative, I know it is positive. You must put that positive sign. If not, it'll look as if it's 3p squared 7. And that is incorrect. And then I'm going to highlight what I have repeated here. And because it's repeated, there's no need to write it 2 times. You can just write it 1 time. 4p minus 7. And there you go. That is factor by grouping. I hope you found this video helpful.